Hello students, welcome to my channel Math Excellence. Today we are starting with the another test, t-test. In my previous video, I have discussed with you about the z-test, what are the conditions, and when we need to apply the z-test. Okay, because already I have discussed with you, if the basic things are not clear to you, you cannot apply any test because it should be very clear that on what conditions, on what type of problems we can apply a particular test, because every test is not applicable on all the types of data, on all the types of problems. Only we have to see the conditions that yes, definitely on this type of data, this condition will be fulfilled and we can go for the this type of test. So today we are starting the next test, that is t-test. So the first condition for t-test is this: the sample size should be n less than 30. Already students, I have discussed with you, if sample size is greater than equals to 30, it means we have to go for the Z test. Okay, but if sample size is less than 30, we will apply the t test. Similarly, t test is applicable for one population if we have, that's why I have mentioned over here single mean, and if we have two populations, so we can apply the t test. Okay, what are the process? Already I have discussed with you guys that what is the first condition of, sorry, what is the first step we have? First of all, take the null hypothesis, alternative hypothesis. Okay, set the level of significance, see the critical value from the table of the t-test, compute the t-test by using the formula, and then at the last take decision. In all the tests, please keep remember, students, these four steps are same. Okay, so if you will clear all these basic things and you just learn these condition, that on what condition which type of test we need to apply, so definitely any problem we can solve very easily. Okay, so this is a t-test formula, students. Already in my previous video, I have discussed with you what is the meaning of x bar, what is nu, what is small s, okay, what is small n. So these things already I have discussed in my previous video. So if you want to again go through one, so you can see my previous video. You can take a reference of previous video which is related to z-test. Now, in t-test, x bar stands for sample mean. Okay, mu is population mean and S is sample standard deviation. Okay, I have mentioned a note, students, and this is very important note. Please note it down. If the value of sample standard deviation is not given, same type of note I have discussed in my last video, which was related to Z test. So in this video also I'm mentioning, if your S value is not given, so what you will do? Then you will calculate the S, and by using this formula you will calculate the S. S stands for sample standard deviation. So it's very important, students. We can see this is the formula of t-test, right? What is the formula? Xy minus nu upon S by under root n minus 1. But when you will apply, when S is given. When S is not given, you will calculate the S by this formula. Then you will get the value of S. But this formula of t test you will apply. And what is the formula? X bar minus nu upon S by under root n. So you can see the difference in both these tests. Many times my student asked me, ma'am, when we are taking n minus 1, when we are taking n. So keep remember this thing now. So when S is given, you will go for this formula in which n minus 1 is given. But when you are calculating sample standard deviation, so at that time you will apply n only. Okay. Then conclusion, already I have discussed with you same. If calculated value by using the t-test is less than table value, accept the null hypothesis. If calculated value by using the t-test is greater than table value, reject the null hypothesis. So these things are very important, student. What is the concept? Again, null hypothesis, alternative, apply the t-test formula, which you have to very clear about this. And the last, you have to take the decision that I should go for null hypothesis or I should not. Okay, and this is the t-test table. So you can see over here, I have mentioned like one tail, two tail. Already I have discussed with you in my last videos as well as in the basic video of hypothesis testing. In alternative hypothesis, we have not equal to, greater than, less than. Not equal to means two tail test and greater than, less than means one tail. In one tail, this is right tail. Okay, and this one is left in. So accordingly, we will apply the table values, and please keep remember these are the degrees of freedom. Okay, degrees of freedom means how like smoothly any variable can move in the data. Suppose your n value is 10. So degree of freedom is always n minus 1. So 9 is degree of freedom for particular data. So it means how freely any variable can move in the data. That's represented by the degree of freedom. Okay. So here is degree of freedom. And here is the value of level of significance. And guys, usually if we are taking alpha is 5%, it means we are talking about 0.05. Please keep remember because in this table they are not giving you 5%. They are giving this in with this 0.05 means they are talking about alpha is equals to 5%. Okay. So let's discuss the examples now. Okay, now already in my previous videos, I was saying the same thing. Okay, first of all, you have to see what is given in the question and what questionnaire is asking to you. Okay, what is mentioned in the question. If meaning of question is clear to you, students, any question you can send. Okay, let's start. A soap manufacturing company was distributing a particular brand of soap. We have a company, soap company. They are selling the soap for a particular brand through a large number of retail shops. They have number of shops, but we don't know how many shops we have. So what is this? This is population because population usually do not usually not mentioned okay in the question. Now before a heavy advertisement campaign, okay, the mean sales per shop was 140 dozen. Mean means average. So they are saying that before the advertisement, the mean sale per shop was 140 dozen. 140 is mean. But I don't know that this is population mean or sample mean. Let's move further now. After the campaign, a sample of 26 shops. Total how many shops we have? We don't know, but they are just taking sample of 26 shops. So what is the sample size? 26 was taken and the mean sales figure was found to be 147 dozen. Okay, so mean sale of 26 shops means sample mean is 147. So in the first line, when they were saying कि before a heavy advertisement campaign, means before the campaign, the mean sales this one. So this is a population mix. For all shops on an average, this is the sale. Okay, done with standard deviation 16. So sample standard deviation is 16. That now the question is that we are saying that can you can you consider the advertisement effective? Effective means my sale is definitely increased. So please remember we are using a word of increased. Okay. At 5% level of significance. So let's start this question. First of all, please see that what is the sample size. What is the sample size? 26 less than 30 or greater than? It's less than 30. So definitely I have to go for T test. That it's clear. Now, what is the first step, students? First step is take null hypothesis. Null hypothesis means they are doing an advertisement and sale is increased. But what you will suppose? No, they have done any advertisement or not. Sale is as it is same. So what is the sale? 140. That but They are saying that after heavy advertisement campaign, sale is effective. Effective is definitely increased. So increased greater than means this thing you will use. So what test you are applying? One tail. And one tail. Which one tail test we are applying? This is right tailed test. T-test formula I need to apply x bar. S is given. Yes, S is given. So I will go for the formula of n minus 1. Apply this formula. Put the values over here. What is x bar? If I am putting the value of x bar, this is 147 minus 140 divided by s and under root n minus 1, which is 25. So when you will solve, the answer is 2.19. This is my calculated value, but I have to go for one tail test, 5% level of significance. So let's go to the table. Okay, one tail already I have discussed with you. This is one tail. 5% level of significance. Now, in this question, how many shops they are saying? 26. Already I have discussed what is the degree of freedom. 26 minus 1, 25. So now you have to see where is 25. This is 25. And corresponding of this and this one at 5%. What is the value? This is the value. So at 5% level of, this is a way guys to check the value. Okay, 5% level of significance for one tail test. What is the table value at 5%? 1.708. No need to again I'm saying learn these values. Obviously you cannot learn. So definitely examiner will provide you these values. Okay, so what is now I'm writing here. So what is my calculated value of T? My calculated value is 2.19, and now I got my tabulated value. This is 1.708. So now with 25 degree of freedom. Done. Now you can see that very easily my calculated value is greater than table value. So if it's stated, already I have discussed with you, reject null hypothesis if you're rejecting null, accept alternative. And what was my alternative hypothesis? Sales increase. So definitely sales is increased. Or you can also say that advertisement was effective. Done. So this is a way to solve any type of question by the t-test. Done. So let's see one more example. What is given and how to solve it. Okay, let's start. Next example is a machine is designed to produce a spare parts for electrical devices of average thickness of this one. Average means mean. How many spare parts they are producing? Don't know. So definitely this is population mean. What is 0.025 centimeter? That now a random sample of 10 spare parts. They have selected 10 spare parts. What is the sample size? 10. Okay. Now they are saying was found to have an average thickness of this one. So these 10 spare parts, what is the average thickness? 0.024 centimeter. With if they are using guys, so it means they are talking about sample. I think it's very easy to understand, right? 0.002 centimeter. Then S is given. Very easy now for me. Test the significance of the deviation at 5%. So they are asking to you that companies producing the spare part of this much average. But when we selected 10 spare parts, we got this one. Are they same? Means same company is producing this, or like suppose a company is producing 1 lakh spare parts, we are choosing only 10. Is it any difference in the average thickness in the spare parts? So let's start. Null hypothesis. No, I think it's clear. No, there is no change. Thickness is same. Correct. But alternative, please see that are we using any word of increasing, decreasing, greater, less than, more? We are not using, so it's just mu is not equal to 0.025. Which type of test? Two-tailed test. Done? Okay, what is the sample size? Less than 30, so t-test. X bar minus mu s upon under root m minus 1. Now put the values. X bar is 0.024, mu is 0.025, S is 0.002 divided by n minus 1, which is 9. So when you will solve it, you will get the solution minus 1.5. Okay. Now what is n? 10. So let's see 10. So n is 10. So what is degree of freedom? This is 9. So 9 is degree of freedom. Total test. So if this one was 0.05, this one in the previous question, this was why? Because I was using one test. Now see what is the value we have. So this is the value. So at 5% of level, okay, for two tailed test. Guys, what is the table value? You can see that what is the table value? 2.262. That okay. So just write over here. What is my calculated value? My calculated value that I got 1.5. We use what? That is two table test. What is tabulated value? That is 2.262. So my calculated value is less than table value. Less than means I have to accept null hypothesis. If accepting null, so it means you are rejecting alternative hypothesis. And what was alternative hypothesis? That the average thickness was not 0.025. So yes, average thickness is 0.025. Done. This is the solution. So in this way you can solve any problem. We'll solve one more problem. Let's see what is we have in this problem. Okay, a random sample of size. Now random sample size is 16, has 53 as mean. So what is sample mean? This is 53. Two things are given and C. Sample size is less than 30. Obviously, I'll go for t-test. Done. Next, the sum of square of deviation. Guys, already I have discussed in my z-test video that sum of square of deviation means this one. This notation, this thing is called sum of squares of deviations. Okay, it's a different question now. Okay, three different questions I am discussing with you. First one was one tip, second one was two tip. Now, sum of squares. What is sum of squares? It's given to me 150. Okay. Now, further, can this sample be regarded as taken from the population having mean mu as mean? So population mean is 56. They are asking to you this sample you are choosing from this population. Is it so? Test at 5%. So what is null hypothesis? You will say yes, we are choosing. Then alternative, they are not using any greater than less than word. So mu1 is not equals to 56. So it's mu only, not mu, but not it's a two-tailed test. Okay, two-tailed test. Then further t-test you are applying, guys. Do you have x bar minus mu upon s upon under root n minus 1? Do you have s over here? No. And I have discussed with you, if you don't have sample deviation, standard deviation, sorry, you will use n. Okay, because you will calculate s. Now I will apply this formula, but before applying this formula, I need to calculate s. How to calculate s? I'll apply this formula. Formula is 1 upon n minus 1 summation xi minus x bar whole square. So put the values 1 upon n minus 1. What is n? N is 16. This is 50. It's 150. Sorry, this is s square. So s square is, if we are solving it, this is 10. Okay, so let me go to next writing. So S is under root 10. So I'm getting S under root. So let me solve this one. S is root 10. So it is S square is root n. Okay, done. So what we are getting, S square is 10. So S is under root 10. So under root 10 value of S is 3.162. Done. Now put in t test x bar minus mu S upon root n. If you are putting the value, what is x bar? 53 minus 56, 3.162. Okay, divided by 16. So answer is minus 3.795. Okay, now check at 5% level of significance for two-tailed test. What is the value of table? Value of t. What is the degree of freedom? Degree of freedom, please keep remember, degree of freedom is 9. Why? Because, sorry, degree of freedom, correction, one second. N is 16. So degree of freedom is 15. So now we will see what is the table value 15. This is 15. We are applying a two-tailed test. This is 0.05. So what is the value we have? This is the value. So table value is 2.131. Then so we can see that calculated value of t is 3.795 and table value is 2.131. So my calculated value is greater than tabulated. Obviously, I have to reject the null hypothesis. Done. So in this way, guys, you